This
um,
conference will
carbon.
now be recorded.
And
Sorry.
and the other thing I want to note is, we've had Allie Menchaca in quite a few times. She came and did when we could have people in. She came and did a natural ventilation presentation. We also had a facade specialist with her come in from your team, come in and give us a presentation on high performance envelopes and how we should be looking at design. And then we've also had Colin Schluss come in and talk about a little bit about Passive House, but mostly about energy modeling and remind me the name of the Design Explorer
Yeah. Okay. Good. Yep.
software or interface that's open source on the internet. So there is no reason why we don't have you on our teams.
I like how you say that. That's so good.
I just don't understand. Let's see, is John Martin on here? No.
John, where's John? Yeah.
I know,
Okay.
where's John? I know he's here, but he's probably in another meeting. But we do we do have, even though Gunnar is located in Maine, that there is a team here in Boston, and there I've never found you guys to not be accessible. So and especially now with COVID, there's no excuse, right? We all know how it doesn't matter where you live. We can all work together.
Good. Well, you're in for a treat too, with Paul Becker joining me here. So obviously Thornton Tomasetti is such a history about structural engineering, and Paul recently merged with Thornton Tomasetti. It's probably now almost 2 years ago now, but Paul's extremely well established and respected in the state of Maine, and it was amazing when he came and talked to us at Thornton Tomasetti about joining us, and we're excited to report that we're now just finally found a space and brought our offices together, even in this COVID time. So not many people are in it, but it's a 40-person office now in Portland, Maine. So it's basically matching about the size of our Boston office in terms of size and capacity. So, well, great. Well, thank you, Kristen, for that intro. But yeah, Paul, jump in. Sorry.
No, I'm glad to be here, and I'm sorry for the little glitch here. I have a webcam that normally is like, spot on, and for whatever reason, it didn't go to meeting, so I was having a little bit of difficulty. So thank you for your patience.
Yeah, no, all good, all good. All right, should we jump in?
Yeah,
all right, great. Well, let me get the screen up here in front of us here. And I know I'm going to go in presentation mode, and it's going to go to the wrong one. And it did, so I'll switch it. Okay, great. Okay, well, we've been asked to come here and talk to you about mass timber framing and designing basically low impact structures as a result. And so I'm going to sort of start off with a bit of setting the stage for a little bit of the embodied carbon talk, and then you're going to be, I believe, fully impressed about I'm setting you up here. Don't let me down here, Paul. You're gonna be impressed with what Paul's gonna share about mass timber's do's and don'ts and opportunities for obviously many of the projects that you guys go forward with. So I'll just do a very brief introduction of myself, and then Paul, you can say to you. So I'm a licensed architect that chose the path of sustainability. I head our sustainability practice, and we are about 25 strong within the 1,500 person company of Thornton Tomasetti. So sustainability then is in San Francisco, New York, Boston, as Kristen shared, Portland, and then also London in terms of where we support projects from. I've been doing this for about, probably 30 years. So early adopter, came right out, went to University of Oregon because of sustainability, as it being one of the best programs at that time and still is, and just came out going, got to make a difference. So I've been an early adopter. Paul?
Yeah, hi, Paul Becker. I'm senior principal with Thornton Tomasetti, also located in Portland, and joined Thornton Tomasetti, our firm did, in April of 2019. Prior to that, I had a firm in Portland for 25 years, 26 people, And we tackled any type of structural issue that you might imagine, from private homes to parking structures, historic restoration, civic buildings, courthouses, everything. But part of what we do here in Maine is we do build with a lot of timber, and I was found early interest in moving to mass timber for some of these larger structures where normally we would see steel and concrete. And once I joined Thornton Tomasetti, I really took this on as a mission to improve how we do buildings and moving towards timber. So Gunnar, take it away.
All right. So as just said, we're a 1,500 person firm basically across the globe. But one of the things I love about Thornton Tomasetti is that there is this drive to be to make a difference. And literally this motto that came in, I think almost 5 years ago, but to be a global driver of change and innovation in our industry. And with me having my sustainability hat on, there's the only way for success, quite honestly, is to embrace sustainability, given the direction. Obviously, we all understand about climate change and really health and wellness. If we are going to affect the work, our buildings and the built environment, the work we do, we have got to be smarter and embrace sustainability. So sure enough, that's even the first slide here, right? Well, all the scientists are directing us towards, we have to do as much as we can in the next 10 years. There's literally there's worry across the board. And actually there was a New York Times article literally just this morning that says there's some hope. China's coming on board a little more aggressively, but is it going to do enough, quick enough? But it was a mix between some positive hope, but also a reality check that we've got more work to do. So I threw this slide in because I don't think everyone really understands what the AIA is doing right now. And so all of you who are licensed architects are headed in that direction. This fact that now when you sign up and you are a licensed architect, that there's this added responsibility in the code of ethics and an obligation to the environment. So you have to, in terms of communicating the responsibility to your clients about the buildings and their operations. So it's important. And I think too, just what the AIA is doing in general, if you're not paying attention, there has been a huge shift in terms of every aspect of the AIA is now about trying to support this big design problem, which is really being part of the solution for climate and carbon reduction and creating a sustainable, healthy, equitable world together. So just a call out to the AIA, I believe I'm very pleased to be on FAIA in my case, but just absolutely when an organization makes such a big shift for such importance, anyway, I'm just hats off to that effort, and all of us should support them. So why are they doing that? Obviously buildings, we know that impact of the environment, but it's today's trying to shift it towards mass timber, but we know there are materials out there, obviously, that we're using more often and too much of, and are we balancing in the quantities? And when you start really drilling into the CO2 emissions versus maybe energy, we used to always think about the energy performance of buildings, but when we start bringing in CO2 emissions, it really drills into this topic of the materials. And so, I think we're getting better. I know we are getting better on the operational carbon, right? We're getting to the point of net positive energy buildings. That's way cool, right? But we're not there yet. We've got a lot of work to do. But the embodied carbon of the materials is now the thing we have to also embrace. So we can't let go of operational. We have to do both and it really comes into where are the materials coming from, how are they manufactured, and are we being smart about how we're using them for our buildings. And when you start looking at this global stock advancing, and obviously COVID's throwing us off a little bit here on how quick we're going to be building new buildings versus retrofitting. But as we look globally and many cities still advancing, we need to pay attention to the embodied carbon. And this is a graph, as you shoot, some of you may have seen this before, but it's just showing, left to right along the bottom is years, but on the left vertical are, tons of CO2, megatons. But when you start taking that many billions of square feet that are being built, now, it's really, we want to think not just of this operational carbon, which progresses as we get that square footage, billions each year, advancing and becoming impacting in terms of climate energy usage. It's this other number, though, of the decisions we make now about concrete, steel, or in this case of today, trying to prioritize wood as a lower embodied carbon material. That's decisions we make today on every single project, where the operational carbon is over the life of the building. So that unique difference. And so, as you said, look at that pie of that combination of embodied and operational. Yes, let's make our buildings net zero, net positive, but it's also this bigger chunk of the pie. Now it exemplifies the importance of embodied energy, embodied carbon. So Thornton Tomasetti, we got this a while ago. I mean, the reality is, majority of our company are structural engineers, but probably only 50% now, where it used to be all we did, and have been changing and evolving as a company. But we've been almost for 10 years now tracking on an annual basis where is the embodied carbon, and we've been reporting on that for the buildings that get built on an annual basis that Thornton Tomasetti is involved in. We've been taking that data and reporting it back to the AIA for their 2030 initiative, because that's all we really at the time had control of. We're now sort of rethinking some of that, but we really understand through all the different market sectors that we're in, where is that embodied carbon? And we've been taking that and then looking at it, and you can see floors in general when we look at that diversity of the market sector. But it sort of shows how, the range obviously is depending on the decisions made with the architects, with the owners, about how to improve upon it. And obviously a tall building versus a horizontal building starts dictating where these percentages are. But it's really helpful. It means that we've been able to take this data and share it with the Carbon Leadership Forum, with research institutions like MIT, with the University of Washington, and it's sort of helped establish some of the baselines. There's a whole obviously separate talk that we can keep going on in terms of embodied carbon with other tools that are out there. But I mean, we feel this is an area, and we're actively part of what the structural engineers commitment are doing in terms of really targeting by 2050 a 40% reduction. And this is just in what the control is of the structural engineer, right? Obviously, there's so much more in terms of the facade and the decision we make on the interior finishes that also have embodied carbon. But this is kind of coming around to where we're headed as a company, along with other initiatives. But something I think is really unique about Thornton Tomasetti, and it comes back to being a global driver, that we're taking some of our profit and we're investing that into tools and techniques to help the industry as well as ourselves. But it's this tool that we created here called Beacon. It's a free Revit plugin that takes your data, and you basically can quickly analyze the structural framing compared to the columns, foundations, walls. And it's giving on this left side of this slide here those quantity takeoffs, and you can start messing with, you can see it's a little hard maybe, but the global warming potential, those are, if you're in a certain part of the country or part of the world where the global warming potential of, let's see, the steel manufacturing is higher or lower, you can adjust that and see how one scheme might affect the others. So that was the point of this little video on the right, is how we can sort of adjust base sizes, materials, and in the lower left here, tracking the embodied carbon of those materials as we assess our structural design. So that gives us knowledge, it gives data, which is so important for our decision making in the design process. And then Paul's going to touch on this a little bit later, but the Ascent Tower is just coming out of the ground in Milwaukee. That will be the world's largest mass timber building. Probably there are others on the books right now that may beat us out, but at this point, we're able to keep on track with this, given everything we know that's going on around the world. So Thornton Tomasetti then is taking this data, this analysis, And then as we work with architects and we work with owners on trying to help make decisions, then we're trying to use this data to bring it forward and look at options. And it's not an all or nothing. When we're talking mass timber, maybe it doesn't work for every aspect of the building. And there are ways of bringing in sort of this hybrid approach. And Paul will speak a little bit about this, but really trying to get this data at the fingertips early on. And we know embodied carbon is sometimes harder to put a dollar amount on. I was actually on the phone recently with the Rocky Mountain Institute. They're in the midst of doing a study on the cost of embodied carbon. So that's something they're shooting to get out in the early part of the year. So just a little flag on that one, Kristen, maybe you can be looking out for that. But what we are good at talking about is like the return on investment of energy. Right, we've been doing that for a long time, but we're having a harder time, and only because it's new, right? It's new to talk about embodied carbon, but what is the cost and the value? And it doesn't always show immediately a return on that investment. And maybe we can talk about this in the Q&A session a little bit more. But when you look at the ramifications of a region and an industry, it's coming down to the importance. We have to do it. So how are we going to talk to our clients about decision making? And maybe we can revisit that here in the QA session. But ultimately, we are here to talk about mass timber. So Paul is going to take it away from here. I know you've had some other sessions on mass timbers, but clearly we are embracing it as absolutely the answer for many projects that haven't necessarily had it as an option in the past. So being able to bring it early enough in thinking about how you lay out your building and the structure, and that's what Paul's going to be able to share with you going forward. So Paul.
Sure. Thanks, Gunnar. So the question, we want to go back to that slide. I just want to make a couple points there. Yeah. That's great. Clearly, we haven't rehearsed this part of it, Gunnar. In terms of the materials we pick for our structures, it's important, and Thornton Tomasetti has been, passing this knowledge through our company. So as we're looking at systems, we want to be aware of the embodied carbon in each of those systems and building products. And I want to point out that most of these building products are carbon positive in that they release carbon to the atmosphere through the production, extraction of materials, and so forth. If you notice, the wood product there is in the negative zone, and really what that's indicating is that for the most part, and there are exceptions, but for the most part, that wood is sequestering carbon through its life and bringing carbon in from the atmosphere, and even after it is harvested, it is transported, it is fabricated, it comes out of the shop to the job site carbon negative. So it never exceeds the amount of carbon in production that it has accumulated during its growth. Next slide. All right, so when we're talking about mass timber, really we're talking about, predominantly people think about CLT, cross-laminated timber slabs. We're also talking about glulam beams and columns. In terms of, and a lot of folks are familiar with the glulams. You're taking really good wood in the outer laminations and lesser quality wood in the core where it's not working as hard, if you will. So with the CLTs, it's a similar idea in that you have a major and a minor axis, and you are putting the best wood, if you will, on the top and bottom laminations in the major axis, also in that middle lamination, depending on what the buildup is. And you can put lesser quality wood in the minor axis. And so a CLT panel is an anisotropic material. It means it has different properties in each of the major and minor axes. Next. And really, these are products that would be considered mass timber. We're going to focus today mainly on CLT, but I do want to point out on the lower right, mass plywood panel. This is really, at this point, probably one manufacturer, Pacific Northwest, but it's a great, a plywood supplier said, hey, I don't want to miss this train, and started producing these panels that are equivalent to CLT. Next slide. So when we talk about CLT, we really want to focus on the 5-ply layer, and that is about a 7-inch buildup. And that is because that is the most commonly manufactured product. And so you're gaining some cost effectiveness and economy there. We see the 3-ply layer often in wall panels, in a bearing wall situation, and potentially in shorter span situations for floors. So with the 5-ply is really where we want to try to head our designs to. And as we lay out structure, we think about this all the time. Next. So who is producing this CLT and where can we get it? Well, clearly Pacific Northwest is a big producer. In the east, you have Nordique Structures in northern Quebec. You have a new manufacturer that's not on this list, Element 5. They're in Ontario, and they are producing a lot. But I want to point out that the Europeans, KLH, Binderholz, and others, are an effective and cost-efficient consideration when we are east of the Mississippi, as many of our projects are. The Europeans produce so much product, and their cost point is somewhat lower than ours. And actually, in terms of embodied carbon, shipping this material from Europe on a container is actually quite economical and sustainable when compared to shipping product by rail or by truck from the West Coast or British Columbia. So we've done studies on that, projects at Harvard, and it's shown that those products can be supplied sustainably. The red dots indicate those manufacturers that also do glue laminated beams. So if you're looking to try to match products and finishes, it's important to understand that. Next. So our approach is, we want to, everyone wants to do the big 25-story mass timber building like Ascent Tower, but sometimes we just can't do that. So our philosophy is let's hit singles and doubles and we're going to score some runs. So we have to get mass timber into the vocabulary of builders and owners. And so our approach is to use it wherever we can. The use of stair towers and elevator shafts as an alternative to masonry in specifically low-rise buildings is a great alternative. As Gunnar pointed out, the bulk of embodied carbon in a structure is in the floor slab, specifically if you have a steel frame structure and a metal deck and concrete slab. A great way to reduce carbon, and it's a great entry point for owners who are a little nervous, maybe contractors who are a little nervous about going to a whole mass timber building. Taking this hybrid approach is a great way to do that. And then clearly the best approach for so many reasons is to use mass timber throughout your structure. Next. So what are the systems that we're typically looking at? We're looking at beams and columns with slabs spanning in that 20-25 foot range. We're looking at intermediate beam layouts where slabs might be spanning 15 feet. So you're trying to, in this case, you're trying to increase your column grid to maybe a 30 by 30 in the center there or in the far right. Whereas on the left, you're maybe a 20 by 25. And then in the lower photo is a point supported system. This is at Brock Commons out in British Columbia. There are no drop beams, no girders, point supported, but it does require a tighter column grid of about 10 to 14 feet on center. Next. So this hybrid approach, like I said, is a great way to introduce CLT into an otherwise steel building. It goes together really well. Steel erectors are not afraid of it, and again, it's a way to slowly introduce it. On the lower right is another hybrid approach, and that's where you might have a podium building, say 5 over 1 or 2, and where we might normally use double-loaded corridors and wood trusses. We do see opportunity here to use CLTs as this floor system, span party wall to party wall, What this does allow you to reduce the overall height of the building, and in most cases, because the CLT 5-ply comes with a 2-hour UL rating, you can expose that ceiling. And it really gives a very nice, again, entry point and a way to introduce developers to this product. We have a project right now here in Maine that this is how we're approaching it. They were a little shy for a full CLT and mass timber building, but this is a great entry point. Next. So what does the code allow, and where are we heading with it, and are there code restrictions? This is a big movement here. The 2021 IBC is recognizing mass timber in a whole new way, and they've developed 3 different categories of type 4 heavy timber construction, which is going to allow us to increase story height and also change the way we approach fire protection. So for the type C, it can be totally unprotected at 9 stories or 85 feet. The type B, up to 12 stories, requires partial protection, and there are formulas within the code that address percentages of either floor or beams columns to be protected. And then the highest, type A, 18 stories, that is fully protected. And that's following really a pattern that was developed at Brock Commons, that point-supported flat plate slab, if you will, project that I showed earlier. That project gained code approval by fully protecting the timber. And I believe that this will be an intermediate step on a road to exposing more timber as we gain comfort and more information. Next. So what the code is really trying to do is show equivalency with the type 4B and type 4A mass timber buildings to what currently are 1A and 1B non-combustible buildings. So you're getting parity in terms of the fire resistance rating and areas essentially. So next. So wood's fire resistance is really developed through char. So the exterior surface of the wood heats up in a fire. The char layer develops, and it really keeps the remainder of the wood fairly cool. And once the fire is usually a result of contents burning, and once the contents are extinguished, the mass timber self-extinguishes as well. Now, the fire is really governed by 2 things. It's the level of content, and it's also the amount of ventilation or the fenestration in the wall system. So if you have, assuming you have the same contents in a room, in a compartment, the more ventilation, the hotter the fire burns, and the quicker it burns, but it extinguishes much quicker as well. With less ventilation, the fire reaches essentially the same temperatures, but it takes a little while, and that fire might burn for an hour and a half, 2 hours. So the ratings that we achieve are based on those test data that we've developed. Next. So that test data includes looking at performance of the timber, but it also includes protection of the connectors. And in some cases, we are bearing wood to wood and we don't have steel connectors. But anywhere that we do have a steel connector, a hidden connection, concealed, we do have to protect it, and we protect it 2 ways: with fire stopping and with locating that connector within the char layer of the wood-to-wood connection. Next. So one of the benefits, if you will, of the new code as it pertains to mass timber and fire is how they deal with concealed spaces. And current code for heavy timber would require sprinkler of concealed space to be sprinklered in many cases. Here, depending on the height and type of construction, the low rise, you may not require any protection because that CLT, like I said, many manufacturers now come with a 2-hour rating. But if you have a drop ceiling, what you need to do is protect that CLT with 1 layer of type X drywall. And then likewise in the type A and B, the taller wood structures, you need to protect that CLT with an extra layer, but there's no sprinkler requirement. So it's quite an add, if you will, for fire protection. It's a positive step. Next. So in terms of other considerations, and again, fire and acoustics perhaps used to be more the purview of the architect, but as we move into mass timber, it really is requiring a closer collaboration between the structural engineer and the architectural firm to determine what the best system is to achieve the ratings that you need. In terms of acoustics, I would recommend that folks look at Woodworks website, and they've got great information there about so many things with mass timber, but particularly around acoustics. They have tested about 400 assemblies, both walls and floors, and looked at the ratings on those systems. And it's easy to achieve greater than 50 STC or IIC on these mass timber floors. We typically see a isolation mat and then some type of a topping, maybe a gypcrete or concrete, and that could be from 2.5, maybe 3 inches. That helps with the sound. You could go to a dry system as well, increasing the isolation mat and using tile, or a completely dry system with wood where you're putting a sleeper system essentially on top. These are considerations for discussion with the contractor because some projects just don't want wet construction after they've set some of the lower levels in place, depending if they're doing top down or bottom up in terms of finishing. Next. So where are we going with timber? Thornton Tomasetti was involved with Perkins and Will and University of Cambridge on a 80-story research project several years back, looking at how we could go taller with timber. We used the diagrid system and made most efficient use of the timber. Think about honeycombs and the strength they have. And this is really work that was instrumental in setting us up for the Ascent project. Next. So Ascent, as Gunnar mentioned, is a 25-story mass timber building. It is currently the tallest in the world. It's under construction. It is 19 stories of wood over 6 stories of post-tension concrete parking garage. And in terms of a little bit about this project, in terms of how they achieved their code compliance, Type 1A construction is usually what we would look at for a building of this size. They explored that as a code path using performance-based criteria, and they did a lot of testing on the timbers. They did the first 3-hour fire test on timber columns, and they showed that they were sufficient to carry the load that was calculated. They came up with the section properties needed, and then it did the calcs, and they tested it. So that was really a positive development for the industry. But in the end, what they decided in discussions with the code officials was to use Type 4 construction with an exemption for height, but they did provide the fire resistance ratings of a 1A type construction. And there were other aspects of this in terms of the firefighting capability during construction, particularly additional standpipes and temporary fire suppression systems. It's most vulnerable during construction, as you can imagine, before all the systems are in place. This project cost a premium of about $750 a square foot, or about a little under 2% of the total construction cost to go to timber. And the developer felt it was a good investment in terms of lease rates and opportunity for quicker turnover and lease up. Next. So what we've been doing is looking at different mass timber systems to try to understand the efficiency and where does efficiency lie. Mass timber pricing, when you're looking at construction costs, is really pretty much a direct correlation to the volume of wood cubic inches per square foot. So we've studied different structural systems, say for residential or hotels. Next slide, please. And we found that if you use a grid, this 16-20-20, meaning the CLT is running the length of the building, if you will, right over the corridor there, and you space your columns out, perhaps in that entry area, or maybe at the bathroom, kitchen locations in many dormitories or hotels or even apartments. This creates probably the most efficient layout using 1,125 cubic inches per square foot. It gives you great floor to floor and is going to cut down clearly on costs, which is what we're trying to really understand. Next. We've done similar studies for office layout, and while the 30 by 30 traditional office can be achieved, what we find is that a grid in a office building of about 20 by 25 with the CLT spanning 20 feet is sort of the sweet spot. Next slide, please. And that is because while it has a little larger volume of wood than the 20 by 20 grid, it is seemingly the best value in terms of space and how the tenants can really use the space. Now, again, it's not to say we can't do a 30 by 30, or for a lab building we can't do a 20 by 40 or 30 by 40. It's just that it comes with additional cost. There are ways to skin that. We can use composite construction, meaning we can attach screws into the top of the CLT or other fasteners, cast a composite with the concrete deck, and obtain longer spans. But in doing that, we're still buying more wood to carry perhaps the additional concrete weight required. So if you can set your grid to 20 by 25 in an office building, you're going to achieve the greatest efficiency, and then in turn have the greatest perhaps likelihood of a successful outcome. Next. So a couple examples. This is a project here in Portland. It's a combination, kind of a hybrid. We tried to do a full CLT building here, mass timber building. Cost didn't allow it, but we used a glulam frame. We used a potlatch deck up on the roof, all considered mass timber. But the infill floor framing, you can see the plan view. It's pretty squirrely there. It's a little bit of geometry going on. But we just compromised, and they put wood trusses, and then a ceiling in that space. But again, the idea is to hit singles and doubles where we can, get it into these buildings, get people familiar with it. This was directed by an owner who wanted to retain employees. They were having trouble retaining staff, and they wanted a nicer work environment, and I think they've achieved that. Next. So here's a project we're working on right now, the University of Maine. This is a classroom and lab building, and the direction here was they wanted us to design this in both steel and timber. So we have two competing designs side by side. Contractor, in this case with Consigli Construction, they priced out both scenarios. And when we went timber, we went all in on timber, meaning we went timber shear walls, cores, timber facade, the whole works. This project costed out at $3.30 more for the mass timber, which is $250,000 on a $54 million project. So really, at this stage, this went to like early DD, but pretty good. We took it further in terms of the data, but it's really very competitive. So we approached this with those situations in mind that I talked about: how to reduce the volume of wood, how to make it efficient, and we were able to do that. Next slide. So the other great part about that is we reduced the CO2 and the global warming potential by almost 40% by going to a full timber building. Next. This is another project that we're working on, also at the University of Maine. They are really pushing wood for their buildings. State of Maine has probably the largest wood reserve in the country, and we are trying to get a mass timber manufacturing plant here desperately. And the state has been funding a lot of studies and concept designs to get there. This is a 300,000 square foot, I'm sorry, 75,000 square foot, 300-foot long laboratory building at the University of Maine with 70-foot and 60-foot clear spans and 4 15-ton bridge cranes, 2 in each building. Everything completely wood-framed building, except for the underslung roof trusses do use, or underslung trusses at the roof do use some steel tie rods. Next. This is another project, Bigelow Labs Ocean Sciences. It's a education center on the coast of Maine. Next. We looked at this project. The direction was given to use mass timber as much as possible. It is a large, long-span structure. Laboratories at the lower level, they were framed in steel and concrete, but the interest was in the offices and the education center to use wood. Facade was wood. We also designed this as a steel. Again, costing was essential, and unfortunately, this did not have as good an outcome. Next slide. Didn't have as good an outcome from a cost perspective, but again, this is a little shot. We did use CLT on the exterior walls. Window pattern was such, we made kind of a Z-shaped panel that was connected. We evaluated it for lateral loads and vertical loads, and we showed that it all could work. Next slide. We showed it all could work, but the bottom line is that project came in about 4% higher using mass timber because of the long spans, and the owner just didn't have the wherewithal to go that direction. That project was put on hold due to COVID, so it may resurface with extra money, and that's our hope. So a couple of extra slides here, and we'll be done. To influence success on these timber projects, it's really important that we get the right team in place, and that's from consultants and all the way down through the contractor. You have to have a team that's dedicated to making this work and not finding ways that it won't work, but finding ways to make it work. And I think the best thing is to get strategies early on to reduce cost, and it talks about really looking at that structural system, the bay size, the layout, thinking about mechanical systems and how they're going to be run, through structure, below structure, and really investing in a lot of upfront planning so that the beauty of mass timber is that it's a pre-manufactured product, and you gain the efficiency by having all these products pre-manufactured and delivered with penetrations, daps, and notches everywhere you need them to be. Highly precise material to the millimeter. So it's really a wonderful product. The other thing to talk about really is how do you procure the material? Is it a design assist or a design build bid approach? Each has their benefits, positive and negative. A lot of folks are going to design assist, but where you gain maybe schedule benefit, you can sometimes sacrifice competitive costing. So it's really, we feel we can design a building that can accommodate most manufacturers and create some competition in the marketplace. Next. Again, the reason we want to use it is it's very quick to go together. It's a lighter material. You use smaller crews. You can use, carpentry crews, and especially in urban settings, there's a lot less noise. We find that general conditions are reduced. The Ascent Tower project, they were really looking at reducing their construction time by almost 4 to 6 months, and that's real money. So I think we have to always be aware of that. It's a lighter structure, so it can reduce foundation loads and also lateral loads due to seismic. It's also a great product to use if you're thinking of a vertical expansion on an existing building. Now, when we get into those, we do have to do a code upgrade for lateral systems, but the lighter the overbuild, the better it is in terms of reducing costs. So, we try to avoid vertical expansions because of that seismic, but sometimes it's the right solution. I think here's an area that most contractors are ignoring, and that affects the price considerably, along with speed of construction, is that, exposing this timber reduces a lot of the cost of finishes, painting, waste, and it's important to find that right contractor on the project who understands these things and builds this into the cost. If you're looking at just a straight structural line item cost, mass timber will more than not come in higher than a steel and concrete building just on the structural cost. But when you start adding in these other things in terms of smaller crews, lighter cranes, less waste, less finish, it can really make the difference and even out those costs. And then again, the supply chain internationally, we should always consider the Europeans. Next. There you have it. And that's our Portland crew right there, whole team.
I was traveling that day, but
well, except for Gunnar.
Except for Gunnar. Well, thanks everyone. Yeah.
Well, I'll open it up to questions and glad to kick it around a bit.
Awesome, thank you. Let's see, did we have anything on the chat? Kristen, do you have any questions?
I had a lot of questions. You answered a lot of them in your presentation. That was great. I guess one question I had that is still remaining is, well, hold on a second. I lost it. We are trying to get this on projects. Like there are projects that are talking about it. And one of the biggest hurdles we have is no one has experience, right? And you mentioned, partnering with the contractor that does have experience. So that hurdle is real. And I guess, are there resources or tools out there that we can use early on? I mean, we have a lot of, I wrote down a lot of your points about efficiency and things like that we know, from presentations we've seen, but how can we really get contractors on board early, and convince them that this is the right path to go?
Well, I think, there's sort of self-selection too among contractors, and there's the kind of the old school. I've been doing this for 40 years and I don't want to change. I know I know how to make money now, but if I change this up, I may not make money. And then there are the contractors who are like, wow, this is really neat. Let's do this. Let's figure this out. And so in that group, what we've seen here, and I'm going to just speak about Consigli as one of them that has been a great partner for Thornton Tomasetti, both here in Portland. They have an office in Portland and in Boston, and we do work with them, in different areas, in DC as well. But what they did was they were committed to learning about this, so they actually sent a crew to another part of the country, to actually the Arkansas dorm project when that was going on, and they reached out to Knobholz Construction, who is a regional player in that that part of the country, and they said, hey, could we kind of shadow you for a week, see what you're doing, how you're doing it, and that's what they did. And they were non-competitors. They kind of hung back and learned what they could learn, and came back and have now a benchmark to spring off of. And so there's that approach. But there are also national contractors who will travel and do this work. And then also some of the CLT suppliers have actually crews that will erect. I think those are areas where you might not have as much cost control, but there are certainly avenues that we can take and look at. Swinnerton is a construction company from the Pacific Northwest that was involved in a lot of the early projects, and they have moved operations to more of the East Coast. I think they have a spot in North Carolina now, but they're willing to travel. Now, it comes with a premium perhaps, but I think we can get it done. I mean, there are avenues to get this done. But
Really
a great
depends on
question.
the scale of the project.
It's a big hurdle.
Paul, the scale of the project probably and complexity would maybe start dictating whether you need that contractor or supplier that's able to push and pull in something. So it comes around to the building type,
Yeah,
right?
and there's a office building in Portsmouth, New Hampshire that just went up at the Pease Air Force Base, 3-story building, and that was erected by the CLT mass timber supplier, which was Nordique. But the general contractor made sure they had their crews there observing every last bit of it, right? So the next project comes along, they're going to erect it and they're going to put it together. So it's just a learning curve like we've done with every other product, right? It's just going to take a little bit.
It seems like it's also maybe less risk versus, say, Passive House or other things we're trying to get our contractors to be team players on. Is that true? I mean, assuming we take, through design.
Sure. I think there is less risk. It's an erector set. And again, the manufacturing is so precise. And the Europeans, again, we've done, we've done private houses, residences in Connecticut with fully CLT manufactured by, who was that? KLH did that one. Everything came over in a container and it was put together in 3 days, and I mean, it fit like a glove. And that's the beauty of it. So I think if we get clearly our structural design right, we do our shop drawings correctly, and we integrate our systems correctly, we spend the time up front, the risk during construction is much reduced. I saw a question about sustainable forestry, and I just want to say that the other great thing about using the CLT product is that you can harvest trees that are much smaller, much younger, and even trees that are maybe considered debris or insect damaged by conventional lumber uses. And because you can use smaller trees, what you're doing is you're harvesting trees where they're at their kind of just past their peak carbon sequestration. So just like young children who need calories, those young trees as they're growing need carbon calories. And as they age, they take in less carbon. So by harvesting younger trees that can replenish in 15 to 20 years, you're actually kind of doing the best of both worlds. You're getting a building product we can use, and you're harvesting after their peak of carbon intake.
Paul, if you're a bedding guy, how quick will we get mass timber in Maine in some of these big warehouses that are just sitting there? It used to be for paper production. Is it closer than, or what?
It is. It is. We're working with a client right now, and they've taken over the Madison paper mill, and they are producing. They've purchased equipment from Europe, and they're going to be producing wood fiber insulation, both board and batt. So a Styco type equivalent. And they are now also looking at bringing in CLT from other manufacturers, finishing it there, building complete wall panels. Okay, so or floor panels, CLT with a direct applied and eventually bonded wood fiber insulation with air vapor barrier, sheathing, strapping, and windows in place, the whole thing. So we have 2 prototype projects, very small, kind of rectangular shed roof, 1,500 square foot addition to building 2 of these, and we're prototyping it right now. So we're helping them figure out how to fasten the wood fiber insulation, 10 inches, okay, on the wall, 15, 14 on the roof. So we've got to anchor it with rotoblast screws, both horizontal and diagonally. So we're working with them right now to develop these wall systems. We hope within a couple of years, that we'll have a full-blown CLT manufacturing plant. The state is working extremely hard with incentives and upfront money to attract a manufacturer.
Yeah, I was curious about that. The project that you showed that was on the boards, where it priced out just a couple % more. Did they end up
Yeah.
choosing wood?
Well, they're fundraising right now, but yes,
Okay.
that's the direction they're going. The University of Maine has the Advanced Structures Composite Center, and they are trying to move wood into a new markets. So they've used glue laminated beams with carbon fiber reinforcement on the tension side. They are looking at CLT right now, and they do a lot of testing for manufacturers like SmartLam. So to get a certification for their panels, they have to go through testing. So University of Maine, University of Oregon are two of the big test centers for wood products. But if you think about that CLT panel with lumber going in the weak axis and the minor axis, that panel is solid. But what we're doing at University of Maine is looking at, well, what if we skip panel those orthogonal layers of wood? So maybe we skipped every other one, and we could run electrical wiring, or we could put insulation in there or do other things. How does it perform? How does it behave? So, we're looking at new ways to use this mass timber to be efficient with it.
And that brings up one of the questions in the chat. Did the wood for the Maine projects come from Maine or Canada, or will it come from Maine or Canada or Europe?
Well, actually, right. So that wood was based around a SmartLam product, which is a spruce pine fir product, at least the ones coming out of Montana. SmartLam has a manufacturing center in Alabama that produces southern yellow pine. But the reason we use the SmartLam, we've teamed with them, and the reason they're doing a lot of research at UMaine is because the Maine forests are also spruce pine fir. And so the information we're learning in this process, in this partnership, is going to allow us to move quickly, to use spruce pine fir here in the state. Mm-hmm. And lesser grades, actually. All good questions. Keep them coming.
So I'm curious about Beacon and a lot of those other software tools that you guys have. Is that sort of integrated into your practice? Like, is that a Revit model you're sort of plugging into that, and then you're getting calculations from it, so that maybe when you make a new model for a client, are you just always plugging that in and always tracking those metrics, or how does that really work in your workflow?
Do you want me to jump in on that?
Yeah, go ahead.
We are. I think if you look across the company, given the scale that we're not every engineer is using these tools the way we envision the future going. But the plugin of Beacon is so easy to get that data. It's then, okay, now what do the engineers do with it? Now that you have it, what does that inform? And so we've been doing more examples of the comparisons of structure to steel to wood, and it's sort of those early design phase. And we've got another proprietary tool called Asterix that's really taking that parametric model and then quickly being able to load it in. And as we're doing the studies of different bay sizes and columns, and that was that little video that you saw, right? It has that embodied carbon number from a broader sense, so it helps inform designs. But I think we're still advancing. Yeah, go ahead. Sorry, Paul.
Well, no, I was going to add to that one of the great things about our combined office and having structural engineers sitting right next to sustainability consultants is that on some of these projects where we've done the embodied carbon calcs, our engineers did the design. With help from sustainability, we learned how to use Beacon and the plugins, and we did all the calculations on our own projects. And the goal is to spread that information, that knowledge base across our office, but also across the firm. And that's 2021 that's one of those things we're working on.
Absolutely.
Yeah, I definitely wanted to point that out. I think you kind of understated the SE 2050, which is really new. And if, I know I've put it on our intranet, so, and I'll make sure to get notes out again that include it. But I just want to point out that if you could talk a little bit about that, and I guess on our end, working with structural engineers or requiring our structural engineers to sign that SE 2050 would be, ideal.
Yeah, no, yeah, we were pretty active in trying to get the language right for that, so it made sense to, and does it have enough of an impact? And I know, I started talking about it's the next 10 years, so you go, is 2050 really the right goal? But it's structural engineers, only so many dials that can be moved, but it's really interesting when you start making those commitments, the decision to buy steel from one manufacturer for another because they're using an electric arc furnace, and in that area of the country or the grid that is getting, greener and greener, more renewable energy. So all of a sudden you can get steel that's recycled using renewable energy, and you're going, wow, there's a difference there. But how much can you change concrete, and how quick can that happen, and the alternates? So there's great research going into it. So I think that's an interesting idea. I think whether it's your structural engineers, your MEP engineers, your sustainability consultants you team with, asking them at a company level where are their commitments is kind of interesting, right? It shows a sort of different level of where the priorities to you as a firm, as well as how you are committing to obviously delivering really high quality projects and design. So I think we're as an industry, we're heading that direction, and I'll step there. Yeah.
Let me add that I think as a profession, we need to get everybody on board, because concrete is a great example. If we want to use carbon capture technology, and it requires a provider, a producer, to invest, hundreds of thousands of dollars in this technology, and we're the only firm asking for it, well, then we become a pain in the neck. We're an outlier. But if everybody is putting it in their specs and requiring it, then all of a sudden that firm, that concrete producer, needs to do that to be competitive and remain in the game. So that's, I think, where groupthink needs to move, is, everybody needs to embrace it.
Awesome. Yeah, I think we're pretty much at time, but thank you, Gunnar and Paul, for joining us. It was a really great discussion.
Great. Well, thanks so much for inviting us and having us.
Yeah.
Thank you. It's really great. Are there any other last minute questions? I feel like I hogged the time.
Well, we're happy to do any follow-up if there's questions that we can help answer. And obviously the ultimate goal is finding some great projects to work on with you all. So we look forward to that opportunity.
Likewise. Thank you so much, both of you. That was great.
Thanks. Enjoy the holidays as well, everyone. Okay.
Thank you.
All right. Bye-bye.